My personal trick are 4 quantum numbers. Remember that you are going to learn my personal trick of 4 quantum numbers through which you can crack any college or entry test questions in seconds. I give you guarantee if you watch this lecture till the end, you will learn my personal trick which no one can teach you. But maybe after this video. The first quantum number is principal quantum number and it is denoted by small n. This number describes the energy levels or shells around the nucleus where electrons revolve. For example, when n is equal to 1, it is K shell. When n is equal to 2, it is L shell. When n is equal to 3, it is M shell. And when n is equal to 4, it is N shell. I call these shells or energy levels as man shells or man energy levels. Thus remember that M starts from 1 and goes up to 4. Here is a bonus MCQs for you. N can never be equal to dash 0, 1, 2 or 3. Well, the answer is 0. N can never be equal to 0 because N starts from 1 and goes up to 4. The second quantum number is angular momentum quantum number or commonly known as azimuthal quantum number. It is denoted by small l. This number describes the shape of sub-energy levels or subshells within man shells. We know that there are 4 sub-energy levels S, P, D and F. We start counting sub-energy levels from 0, 1, 2 and 3. So when L is equal to 0, it is S subshell. When L is equal to 1, it is P subshell. When L is equal to 2, it is D subshell. And when L is equal to 3, it is F subshell. Now what is the relationship between man energy levels N and sub energy levels L? Well, the relationship between them is L is greater than or equal to N minus 1. But I do not use this formula. I use my personal trick. Now listen carefully. When N is equal to 1, it is K shell. N is equal to 1 means that K shell has one sub-energy level S. And we know that for S, L is equal to 0. So when N is equal to 1, L is equal to 0. Secondly, when N is equal to 2, it is L shell. N is equal to 2 means that L shell has 2 sub-energy levels S and P. And we know that we start sub-energy levels from 0 as 0 and 1. Thus when N is equal to 2, L is equal to 0 or 1. Thirdly, when N is equal to 3, it is M shell. N is equal to 3 means that there are 3 sub-energy levels S, P and D. And we start sub-energy levels from 0 as 0, 1, 2. Thus when N is equal to 3, L is equal to 0, 1 and 2. Fourthly, when N is equal to 4, it is N shell. N is equal to 4 means that there are 4 sub-energy levels S, P, D and F. And we also know that sub-energy levels start from 0 as 0, 1, 2, 3. Thus when N is equal to 4, L is equal to 0, 1, 2 and 3. Also noted down that this S is the subshell of N is equal to 1 or K shell. So I put 1 with it. This S and this P are the subshells of N is equal to 2 or L shell. So I put 2 with S and 2 with P. These SPDF are the subshells of N is equal to 3 or M shell. So I put 3 with S, 3 with P and 3 with D. These SPDF are the subshells of N is equal to 4 or N shell. So I put 4 with them. Now how can you use this trick in any exam to find the values of N and L? For example, consider 2p. Well, always write SPDF and 0, 1, 2, 3 at one side of the page. Here n is equal to 2. The value of p is 1, so L is equal to 1. Hence for 2p, n is equal to 2 and L is equal to 1. Consider 3D. Here n is equal to 3. The value of d is 2, so L is equal to 2. Hence for 3D, n is equal to 3, L is equal to 2. Consider 4s. Here n is equal to 4, the value of s is 1, so L is equal to 0. Hence for 4s, n is equal to 4 and L is equal to 0. Consider 4f. Here n is equal to 4, the value of f is 3, so L is equal to 3. Hence for 4f, n is equal to 4 and L is equal to 3. By this way, you can find the value of n and L using this trick. The third quantum number is magnetic quantum number. It is denoted by m sub L. This number describes the orbitals within a subshell. Well, we define orbitals as the three-dimensional region around the nucleus where probability of finding an electron is maximum. Now, what is the relationship between subshells and orbitals? Well, the formula is m is greater than or equal to negative L and m is smaller or equal to positive L. But again, I do not use this formula. I use my personal trick. We know that when L is equal to 0, it is S subshell. What about the possible values of ML? Well, go from negative 0 to positive 0. We know that there is no negative or positive 0. Hence, the possible value of ML is 0. Thus, when L is equal to 0, ML is equal to 0 and S subshell has one orbital. Secondly, when L is equal to 1, it is P subshell. What about the possible value of ML? Well, go from negative 1 to positive 1. Negative 1, 0, positive 1. Thus, when L is equal to 1, ML is equal to negative 1, 0 or positive 1 and P subshell has 3 orbitals. Thirdly, when L is equal to 2, it is D subshell. What about the possible values of ML? Well, go from negative 2 to positive 2. Negative 2, negative 1, 0, positive 1 and positive 2. Thus, when L is equal to 2, ML is equal to negative 2, negative 1, 0, 1 and 2. And D subshell has 5 orbitals. Fourthly, when L is equal to 3, it is F subshell. What about the possible values of ML? Well, go from negative 3 to positive 3. Negative 3, negative 2, negative 1, 0, 1, 2, 3. Thus, when L is equal to 3, ML is equal to negative 3, negative 2, negative 1, 0, 1, 2, 3 and F subshell has 7 orbitals. Also remember that every orbital can hold only 2 electrons. Now listen carefully. S subshell has 1 orbital, so it can accommodate 2 electrons. P subshell has 3 orbitals, so it can accommodate 6 electrons. D subshell has 5 orbitals, so it can accommodate 10 electrons. F subshell has 7 orbitals, so it can accommodate 14 electrons. Now the final and fourth quantum number is electron spin. It is denoted by m sub s. This quantum number describes the motion of an electron within orbital. The possible value of electronic motion is ms is equal to positive negative 1/2. Remember that electron either moves in upward direction or in downward direction. If electron moves in upward direction, its spin is positive 1/2. If electron moves in downward direction, its spin is negative 1/2. Lastly, how can you find the 4 quantum numbers? Well, consider 2p having 5 electrons. First of all, always write SPDF and 0123 at one corner of the page. We know that here n is equal to 2. The value of P is 1, so L is equal to 1. We also know that the possible orbitals of L is to go from -1 to +1. -1, 0, 1. What about the value of ML and MS? Well, there are 3 orbitals. Each orbital can accommodate 2 electrons. So first electron, second electron, third electron in upward direction, then fourth electron and fifth electron in downward direction. Remember that it depends on you. Either you place the electron in upward direction or in downward direction. The last electron is in the 0 orbital, so ML is equal to 0. The direction of last electron is downward, so the value of MS is equal to -1/2. The second example is 3D having 7 electrons. We know that here n is equal to 3. The value of D is 2, so L is equal to 2. The possible orbitals of D is to go from -2 to +2. -2, -1, 0, 1 and 2. Here, firstly I start placing electrons in downward direction. First electron, second electron, third electron, fourth electron, fifth electron, and then I start placing electrons in upward direction, 6th electron and 7th electron. The last electron is in -1 orbital, so the value of ML is equal to -1. Also, the direction of last electron is in upward direction, so the value of MS is equal to +1/2. I hope that you have learned this trick of quantum numbers. This was all about the 4 quantum numbers.